In this video, let's practice on simplifying the exponential expressions. To simplify an exponential expression, we need to use a bunch of exponent rules. So I listed them here for easy reference. This is our toolbox. Let's take a look at the expression we are given here. Our strategy here is to get this expression into a form where we have each variable with its own exponent, kind of like x to the power of something, okay, let's say m, times y to the power of something, let's say n, divided by x to some other power, p, and also y to another power, q. Okay, now each variable or each factor has its own exponent. Once we have something like this, we can easily use our product and quotient rule to combine those like variables. Okay, so to get our expression to this desired form, the very first thing we are going to do is to take care of this radical in the numerator by converting it into an exponential expression. Look at our toolbox here. This one connects the radical and exponents. Let's match our radical expression to the form on the right. So in this expression, the base is x squared multiplied by the y to the power of 4. Then we have this radical sign. So the power is 3. If the index here is not explicitly written, it means the index is 2. So applying the formula, we take the base, x squared, multiplied by y to the power of 4, raised to the power of m, which is 3, and then divide that by n here, which is 2. Now we have changed the radical to the exponential expression. So we have x squared multiplied by y to the power of 4, then to the power of 3 over 2, then divided by x to the power of minus 4, y to the power of 3, to the power of minus 1. Now that the radical is gone, and we are working purely with exponents, our next move is to distribute the exponent outside of the bracket so we can separate the x and y components inside the bracket. Let's focus on simplifying the numerator. So we have a power of a product of two vectors. So this is a power of a product. So we can apply this rule to distribute this outer exponent of m to each of the factors inside. So we can rewrite this as one factor x squared raised to the power 3 over 2 multiplied by the other factor, y to the power of 4, raised to the power of 3 over 2. Similarly, we can do the same for the denominator. Again, we can distribute this outer exponent, minus 1, to both factors inside. So we take x to the power of minus 4 and raise it to the power of minus 1. And then we take y to the power of 3 and raise it to the power of minus 1. Alright, now we've successfully separated the x and y components in both numerator and denominator. But you see that each of these components still have a power raised to another power. For example, in the numerator, we have this x to the power of 2 and then raised to a power of 3 over 2. And this we have raised to the power of 4 and then raise it to the power of 3 over 2. And we have the same for the factors in the denominator. To simplify them further, we need to use this power of a power rule. This rule tells us that if we have a base being raised to a power of m and the result is being raised to another power of n, we can simplify it by multiplying the two exponents together. So for the expression we have here, we can do x, we multiply their exponents. So we have 2 times 3 over 2. For the y, we have y, 4 times 3 over 2 divided by x minus 4 times minus 1. And for y, we have 3 times minus 1. All right, then simply this can be written as x 2 times 3 over 2 is 3. Then times y, 4 times 3 over 2 is 6. And then divided by x, negative 4 times negative 1 is positive 4. Times y, 3 times minus 1 is minus 3. Now you see we have successfully separated each component with its own power. So we have transformed it into our desired form. To be clear, I can write it as x to the power of 3 divided by x to the power of 4 times y to the power of 6 divided by y to the power of minus 3. At this point, we can bring in our product rule and quotient rule, which allow us to combine the two factors with the same base into a single factor. Because now we have the x terms in both numerator and the denominator, and similarly y terms in both numerator and denominator. So we'll need to use this quotient rule to simplify these sets of terms. Remember, the quotient rule tells us that when we divide terms with the same base, we subtract their exponents. So let's apply the quotient rule. For the x terms, we subtract their exponent. So it's going to be x3 minus 4. And for y terms, again, we subtract their exponents. 6 minus negative 3. This equals x3 minus 4 is minus 1. And y to the power of 6 minus negative 3 is 6 plus 3, which is 9. Now there's one final detail we need to address. The question asks us to express our result with positive exponents. We see that the x factor has a negative exponent. To convert this to a positive exponent, we'll need to use the last formula in this toolbox, which is the negative exponent. If you have a base raised to a negative power, you can rewrite it as 1 over that same base raised to a positive power. So applying this rule, we can rewrite x to the power of minus 1 as 1 over x to the power of 1. And the y to the power of 9 already has a positive exponent, so it stays as it is. Therefore, the final simplified expression with positive exponent is y to the power of 9 over x. So this is the final answer. Thank you for watching. If you have any questions, feel free to leave them in the comments below.